some electrical advice for setting up your home workshop. Let's take a look. What's happening, guys? Welcome back to the workshop. Now I'm going to put my electrician's hat on again for this video because I've been getting a lot of questions lately, emails and messages and the like, about an electrical installation for a home workshop. What should you be thinking about? What should you ask your electrician? What layout to go with? And so I'll try and address some of those questions in this video without getting too into the weeds of an electrical installation. Just try and give you guys some good advice, some good things to think about if you're planning your home workshop. So that's what this video is going to be about. I'll attempt to address some of those questions. I also want to talk about extension leads and the dangers of using extension leads. So if you've got lots of these in your workshop, you really shouldn't. And we'll try and get you an electrical installation so you can avoid using these. And I'll give you a demonstration with some tests about why extension leads can be quite dangerous and are not a good option in a workshop. So without further ado, let's start at the start, and that is the mains cable to your shed, your garage or your workshop. Let's look at that. Okay guys, so let's start at the start, and that's our mains cable to our workshop. So we have a couple of things we want to think about here, and I'm going to keep this short and sweet and just kind of to the bullet points. So I'm assuming you guys are like me, or this video is aimed at people like me whose workshop is on their property, so you'll be taking a supply out from your house. So you'll be taking a sub board out to your workshop from your house board. So the first thing we want to think about is the load in your workshop. What are you going to be running in your workshop at any one time? For me, it's my dust extractor, one of the machines, possibly my air filter and my lights. I can't run any more than that at any one time. I'm just one person. But if you're going to have more than one person in your shop or more than one machine running at any one time, that's what you need to think about. Another thing you need to factor in is the distance of the run. So how far is your workshop, your garage or your shed from your house? It's not just the load that determines the size of a cable, it's also the distance. So the bigger the load, the bigger the cable, the larger the distance, the bigger that cable needs to be, because the longer the cable gets, the more resistance is in that cable, the less current it can carry. So it has to be oversized for its distance as well. And there's another important factor for that, which is what's known as the fault loop impedance. We want to keep that as low as possible. I'll get into that as this video goes on. I'll explain a bit more what that is. But so my first advice, the very first point is size your mains cable to your load and to the distance and to future expansion. So ask your electrician to oversize this cable. It will help with everything in the future. So you'll be able to expand in your workshop. It will keep the fault loop impedance down low, and it should, a little bit of money spent here should save some money in the long run. So mains cable, calculate the load, the distance, and oversize it. That's my first bit of advice. Actually, before we move on from the mains cable, just a couple of quick points that I should point out. If your workshop is a long way from your house, so if you have a large property and you're intending on putting your workshop down the end of a field a long way from your house, then it would make a lot more sense for you to get a separate supply for the workshop, because the cable size you would need to run such a long distance would just, the cost of it would be too prohibitive. It wouldn't make any sense to try and take it from your house, so a separate electrical supply for that would make more sense. The type of cable that you will use will be an armoured cable, so more than likely you will be running this underground, or if it's on surface outside, I still recommend that you use a armoured cable, and ductwork from your workshop to your house will more than likely need to be put in. Again, it depends on your garden and your property. So you just need to factor in some of these things when you're thinking about the cost. Potential ductwork will have to go in. It will need to be an armoured cable, and you might potentially have to run another earth with that just to keep the loop impedance value low. So let's move on. That's just some things to consider for your mains cable. Okay, just quickly talk about the sub board itself. Now, we're not going to get too in-depth into this because you will need an electrician to work on that. In Ireland, it's illegal for anybody to work on a fuse board other than a registered electrical contractor, so I'm not even going to open this thing up and get into it. But just to give you a few little pointers, keep your sub board where it's reachable, so don't put it way off up in the sky where you need to get a ladder for it. There is actually a regulation height on these, and they're not to go any more than 2.1 meters to the top. So if you can even keep it down lower than what I have it here, better again, it's somewhere where you can get to, access it without needing a ladder or anything like that to reset the breakers if you need to. Allow plenty of circuits, so when you're asking your electrician to set out your workshop, ask him to allow plenty of circuits and room for expansion as well. Don't put in a small subboard, pack it full of breakers and then have no room to add any extra breakers, because some of the machines you might upgrade to in the future, say a larger bandsaw or a larger planar thickness, or as you grow into your workshop, they might need a dedicated circuit all on their own and you won't be plugging them into a socket circuit. So that's just a couple of things to think about with the subboard. Think about its location. Do not, under any circumstances, put this inside a press or anywhere you can't get access to it. Keep it at a height that you can reach without a ladder, and allow plenty expansion in this for future development as you grow into your workshop as well. Now, let's move on and look at the electrical installation itself. Okay, so let's look at the electrical installation itself. Now, this is where I get the most amount of questions. So you guys are generally at the stage where you're cladding out your workshop, you're putting up the sheeting around the walls, and you want to know, should I put the cables behind the walls? What should I do? Should I do a surface job or a behind the scenes, kind of behind the cladding kind of job? And I always recommend someone to keep it surface in a workshop and keep it modular. Now, it's a lot cheaper to run all your cables behind the cladding and just come out through it and mount your switches and sockets. It's quicker and it's easier, but it's not very modular. So it saves you a little bit of cost up front, but it'll cost you more to add to that kind of system down the road. So spend a little bit more money at the start. Get a header trunking all the way around your workshop if that's feasible to do so, and drop off it where you need to. So it keeps the system nice and modular. So if I want to add to this circuit, as you guys have seen me do in multiple videos, I just need to take the lid off that trunking and I can run cables straight around my shop. It takes me minutes, and I can drop off it in a steel conduit to add a point. I can take away a point. I can chop and change my workshop, and it's a lot quicker, a lot easier. And it'll cost you less money in the long run to add to that system. A little bit more money up front, but less money in the long run to add to it. And keep all the switches and sockets metal clad as well, so you want metal switches and sockets. The plastic stuff is not great in a workshop. You swing around an 8x4 sheet and you catch one of those plastic sockets, it will be just left in smithereens and you have exposed live terminals, which is never good. So a robust system for a workshop is what I recommend, and a modular system for a workshop. So you can drop light switches, sockets, power points, isolators, anything you want inside in that shop, and it's nice, quick and easy once that system is installed to add to it and take away from it. So that's what I recommend. Okay, so there's a couple of points on circuits themselves. So let's look at some socket circuits. Now, I always recommend that you keep plenty of circuits, not plenty of sockets. You want plenty of sockets, but on plenty of circuits. So we don't want to put like 10 sockets or 6, 7 sockets in a workshop all on the one circuit. Again, one thing we have to always remember is that loop impedance, and I'm going to demonstrate that for you, like I said, and I'll explain a little bit more when it comes to the extension leads. So we got to think of the distance of the run. So the more sockets we're adding, the longer that circuit is getting, the load it can carry is going down by the time you get to that end socket, and the number of machines that you're going to be plugging in. You don't want to be plugging in 10 machines into one circuit. Some machines might require an individual circuit. So when it comes to your socket circuits and like that, things like that, plenty of circuits, not plenty of sockets on a circuit. So keep it maybe 3 or 4 sockets per circuit. That'll allow you to plug in a couple of machines to that socket circuit, and it will also keep the distance of that run down. So if you think about it, here's my first socket on this circuit. So it's out from my board, down here, back up, across to here, down here, back up. So I'm adding meters all the time. And if I get around my workshop and I've gone up and down the walls, I've probably added 30 meters of cable to my mains cable back to my house and out. So it gets way too long, the loop impedance will be too high, and that gets dangerous, and I'll show you why in a minute. Okay, so that's just a brief thing on the electrical installation itself. Again, keep it modular, keep plenty of circuits, and keep a small few sockets on each circuit. Keep the length of each circuit as short as possible. This will pay off in the long run, believe me, and allow for future expansion. So that's kind of it on electrical installation. Now I'll do a small bit on lighting. There's a myriad of options you can go for here, so I'll just give you a look at what I have and give you a few recommendations. Okay, so very briefly, just discuss some lighting. I get some question about what light I use in my workshop and what do I recommend. Well, plenty of light and plenty of daylight as well if you can get it in your workshop. If you can't get daylight, then you want daylight colored lighting. So cool white is what I recommend, and put in plenty of them. Now I have 5-foot corrosion proof fittings. They're all LED. So again, high efficiency lighting, put it in your workshop. You don't want to be losing all your load to your lighting, because your lighting will be on all the time in conjunction with your machines, and put in plenty of it. You can switch it any way you want. You can put 2 lights per switch, 1 light per switch. You don't have to have it all on at one time, but when you need light, you really need light, and keep it to the cool white daylight color as much as you possibly can. Warm white looks good inside in the house or for displaying stuff in a window. It's perfect for that, but when it comes to working in any kind of work condition, you want good color rendering, and you want light that's easier on your eyes, and that's down towards the cool light spectrum or towards the daylight light spectrum. So I have plenty of lights in my ceiling, and it still wasn't enough. I still had to put another light over my lathe because I found I wasn't getting enough detail at my lathe. So little things I had to think about. You might want to put lights over individual machines, especially if you're getting a little bit older. You're going to need a hell of a lot more light, and even when you're younger, you don't want to be straining your eyes. So like I say, keep it to the cool end of the spectrum, match it to daylight as best you can, and put in plenty of it, because you will want it in your workshop, believe you me. So let's move on. Okay, let's talk about extension leads. Now, should you use extension leads in your workshop? Or should these be a permanent solution for anything? Absolutely not. These should not be permanently in place in use anywhere. These are for temporary use only. Extension leads can be extremely dangerous. So something I want to try and drum into you guys as you're watching this video, it's not just the load on the circuit, it's not just the thing that you're plugging in, it's the distance of that circuit as well, and it's fundamentally important. So you think about it, that's a 20-meter extension lead, and if I plug that into the last socket or the furthest socket from my board in my workshop, then I've just added 20 meters now to that circuit when I plug in here. Now, if the resistance of that circuit gets too high, the breaker will not trip on short circuit. And I'll demonstrate that with the meter for you in a second. I'll give you some readings and you can see just what this does. So that's one thing to think about. They should not be left permanently in place anywhere. Another thing to think about is never ever plug another extension lead into another extension lead. Again, you could be plugged into the last socket on a circuit. You've just added 20 meters. If I was to plug this extension lead into this extension lead, say I only wanted to go an extra meter further and I was just a meter short, so I thought, I know what I'll do, I'll go and grab my other extension lead, I'll plug that into it. Well, you've just added another 20 meters to that circuit now. What happens if you get a damaged cable or a damaged tool that you plug in there? If you get a short circuit, what will happen is it won't blow out the breaker. It'll turn that whole circuit into a heating coil, and those cables will glow red hot, and that breaker will not go out. I saw it once, a guy changed the light fitting and he drove a nail into the ceiling through the cable. Now, whatever resistance was in the nail, it wasn't enough to blow out the breaker. It was a long lighting circuit in the house, and it turned every one of his lighting cables into red hot wires. So when I got up in the attic, it looked like laser beams were crisscrossing his attic. All the insulation had melted from the cables, and up his walls, down his walls, all around his house were red hot glowing wires. So that's the danger. You're adding distance or length to the cable. The loop impedance is going up. The higher the loop impedance, the lower that short circuit current will be. And if that short circuit current is not correct for the breaker will not blow out. The larger the breaker, the lower that loop impedance has to be. That's something to remember. So always think about the distance of your electrical circuit, the length of that run when you're using extension leads. Another thing I think about an extension lead, especially the drum type ones like these, when these are running close to their capacity, they begin to heat up. So one byproduct of any electrical circuit when it comes to resistance is heat. And as heat increases, the current carrying capacity of a cable decreases, and you can get a runaway problem. So if I only need a meter of cable, so if I wanted to plug that into a socket there, I wanted to plug my tool in here and I wanted to work over here, I'm heating up this cable, and when it's all wrapped up like this, it can't dissipate any heat. So it gets hotter and hotter and hotter. As the heat goes up, the resistance goes up, the hotter this cable will get, and it's a fire hazard and it can melt. So if you have these permanently in place anywhere, that's another danger with them. So I really don't recommend them. They're good for a single use purpose, and always roll this cable out. So when you're using a drum type extension lead, roll out the full 20 meters, even though it might look ridiculous. You're dissipating that heat when it's all rolled out. Like I say, when the heat goes up in a cable, its current carrying capacity drops off, and it begins to drop off exponentially. So you can have like a runaway situation where I've seen it before, believe me, and it's not pretty when it happens in a house. And you do not want to be turning the electrical cables in your house into a heating circuit. So that's just one thing to think about. That's why these things are only good for temporary use. You shouldn't use them either whether you have overhead extension leads that recoil up. I don't recommend them either, because again, you've added 10-20 meters to your circuit. You have a coil that can turn into a heating coil. You're not fully unrolling that coil. So be very careful with these things. They can be quite dangerous. Especially you guys, if you're into your gardening and stuff, you have a big long garden, maybe you have an electric lawnmower or an electric hedge trimmers. They come with a big long lead as well. So you've plugged a big long lead on your trimmers into a big long extension lead. Now you're miles from your fuse board. You are not protected by the breakers in your board. If that thing shorts out, it's not going to trip the breaker. So it's just something to think about there. So let me demonstrate that for you with the meter, just how much resistance one of these things can add to a circuit. Okay, so let's tie this whole thing together about fault loop impedance, what I've been talking to you guys about since the start of the video. And it's important when it comes to designing your electrical circuits or having a conversation with your electrician. They will understand this about keeping circuits short, keeping cables oversized. It's not just the load, it's also the fault loop impedance, which means the total resistance of that circuit, like I said. So we're standing here because that's my furthest socket. That's the longest distance run from my fuse board or from my sub board in my workshop. So it goes back from this socket all the way to my sub board, to the one in my house, and back out to the transformer from my electricity supplier and back in again. It's that total run of that circuit in and out that I will be measuring now in a second, and I'll show you why that's important. And it ties into the whole extension lead thing as well, and the design of electrical circuits. So that's why I'm kind of harping on about this. So we have MCBs, miniature circuit breakers, trip switches, or breakers, whatever terminology you want to use. And these have a set fault current that's required to blow them out. Now these are B-type, which are domestic ones. You will use different notations depending on where you are in the world. But these require 3 to 5 times tripping or max load current in order to trip them out, and they're designed to blow out in 1/10 of a second on short circuit. So we have to ensure that resistance of our circuit is low enough that we get on short circuit that 3 to 5 times current to blow this guy out. Because if we don't have that, this will not blow out quick enough. That whole circuit, like I said, will turn into a heating coil, and we really don't want that. So this is a 10 amp one, so that would need to be 30 to 50 amps we need to flow in an instant when we get a short circuit to blow this trip switch out. My sockets are on a 20 amp breaker, so I need 60 to 100 amps to flow in an instant to blow out the trip switch for my socket circuit, to ensure that I don't turn my socket circuit into a heating coil. So let's test the loop impedance here now, and we can test the short circuit current that we would get on short circuit with the meter. I'll show you that, and then we'll add the extension lead and I'll show you that, and let's have a look at what difference it makes. Okay guys, I have my meter plugged in now. Don't worry if you don't understand this. I just want to show you a couple of figures just so this kind of hits home about the length of a circuit. So you can see I have 240 volts here, and I'm measuring my live and my protective earth. My light has gone off there now. My protective earth. So it's, like I said, it's all the way through that socket, back to my board, back to my house, back out to the transformer, and back in on the earth. So that's the fault loop, it's called. So if I shorted out the live and earth, I need to know that I'm going to get that fault current to flow to trip out my breaker. So if I hit the test button there now, it'll measure the total impedance of this circuit. Now we call it impedance, we don't call it resistance, because there's no such thing as a purely resistive circuit. There's also capacitive reactance and inductance, which causes, it's the total amount of thing that's impeding current flow. So we can just take it as resistance just for this video. So 0.65, so that's pretty small, so that's pretty good. I know I'm pretty good there. That's the total resistance of that circuit all the way out to the transformer. So if I switch over to here, this will tell me what current will flow if I was to short out those two cables. So there you go, 364 amps would flow in an instant if I was to short out that live and that earth. So I know that's well over 3 to 5 times the tripping current for 20 amp MCB. So I know I'm good. That will blow out my MCB if I get a short circuit. But however, let's add our extension lead there now and do this test again. Hey guys, now I'm plugged into my extension lead. So my extension lead is plugged into that socket and I'm now plugged into this extension lead. So if I do my loop impedance test again, we'll see how much this resistance, this extension lead adds to the circuit. So there you go, we've almost doubled the resistance of the circuit just by adding the extension lead. So you can see they can add quite a lot. The cable on this extension lead is quite small. I've oversized my socket cable. I've also oversized my mains cable to keep that loop impedance low. So you can see I've doubled the resistance of the circuit just by adding one extension lead. Now, if I go to my short circuit current, let's see what we get now. So it's now down to 182 amps. So I've halved it. So you can see I'm getting very close to the point where that breaker is not going to short out. And I've oversized my socket cables and my mains cable to keep this down. So you can see the danger of an extension lead. So let's just add the second extension lead now and see what happens. There you go. We've jumped up to 1.96 ohms now. So if I go to the short circuit current, let's have a look at what we're going to measure there. Okay, so we're down to 122 amps now, so we're getting very close to the limit of this breaker, what it needs to blow it out. So you can see the danger. Now, again, I've oversized my socket cable, so if I had to put in 2.5s for my socket circuit, which would be technically fine for the load carrying capacity, but not for the distance. This is where it's important. If that was a 2.5 cable, I would be gone down now to 100 amps or below, and that on a short circuit. So if one of these extension leads got damaged and they shorted out, it mightn't blow out the breaker and I could end up with 2 red hot extension leads, red hot cables back through my conduits, back to my fuse board, and that breaker may not blow out and I could end up burning down my workshop. So that would not be good. Okay guys, so there you go. Just wanted to illustrate the dangers of using extension leads. Adding an extension lead to an already long circuit can push it over the threshold of what that breaker needs to blow it out, and it's also just kind of kills 2 birds with the 1 stone there. So you can see the purpose of keeping your circuits short and possibly oversizing the cables for your circuits in order to keep the resistance down. So that's why your mains cable can be oversized, why you should keep all your circuits short, and why you should never use extension leads as a permanent solution. You could just potentially turn them into a heating coil. And if you get the wrong reading on a circuit, you have a couple of options. You either have to rewire it, then you have to run an additional earth to bring that loop impedance down, or you need to downsize the breaker. So the smaller the breaker, the higher that loop impedance can be. The larger the breaker, the lower that loop impedance can be. So if you think about it, if that was a 40 amp breaker now, we would need 3 to 5 times tripping current. So that'd be 120 to 200 amps to blow it out, and you can see we wouldn't have that on that circuit now, so we couldn't use it there. We would have to downsize that. So if I saw that on a socket circuit, I would be getting pretty worried, and I might have to downsize it to a 10 amp. So there we go guys, that's just something to think about when it comes to putting in electrics in your workshop. Okay guys, there you go. Hopefully you found that useful. So just quickly to recap again, oversize your mains cable, allow for plenty of expansion in the future. Think about the distance your workshop is from your house. It might make it prohibitive to take the supply from the house. It might need a standalone supply. Again, keep things modular, keep it metal, keep it safe, and that's the way to go. Again, a little bit of money up front always saves money down line. And like I say, if you keep a nice modular system like what I have in the shop, it's easy to add and take away from and chop and change as you grow into your workshop. And you can see the dangers of extension leads. They're only good for a temporary option. They're never ever good for a permanent option. You think you're safe, you think you have breakers in your board that are protecting you, but when you add to a circuit like that, those breakers are no longer doing the job because the resistance of that circuit is gone up too much. So there you go guys. Hopefully, like I said, that answers some of your questions. Hopefully it gives you some more information. If there's any comments, any questions you have for me, anything you think I've left out, leave them in the comments section below. It's just a few few little things to think about when you're planning your home builds. Like I say, I've got a lot of emails and a lot of questions about the electrical installation, and most of you guys wanted to know what things to think about and what to ask your electrician when you want to set up your home workshop. So hopefully that gives you guys some information, and if you're enjoying this electrical content, I don't mind doing some more of it. I can give you some basic advice without getting super in-depth into it, and it should help you guys out setting up your home workshops. So there you go, guys. If you liked the video, give it a thumbs up. If you're new here, think about hitting the subscribe button, and like I said, comments and questions below. I'll always get back to everybody, and all the resources to my videos are below in the comment section as well, or in the description below the video, I should say. Now, I'm going to get out of here, guys. I'll see you in the next one. Take it easy.